Okay, so continue on. Once I have my green, I'm just going to start bringing um, continue typing. So the next one would be CPU memory map. Within my memory map, so just like I showed you in the header, we had within our header all those predefined names that we can use. Those names we can't use again unless we're using them as such. So within this section, don't ever use the ports or anything else again. Those are already predefined. So in my example, I put one count count. What is that? Equals tab equals, and I can put in a 0x20. And then I need to add a comment. Comment is used for delay loop, and we'll talk about delays later on. But now this name is associated within my memory of a hex 20. And if we go to your memory map, so if we were to look at your data sheet, and we go to the memory map, which is in the first part of the book, when I say that it's at 20, what that is down here in bank 0, I've given it the address of 20H. Count 1 is now associated at this register. And then if I did another one, I'd put in 21, 22, 23, and I could go all the way down to 7F and have enough room. Let's go down here, because that was 882, this is 883. I could also use this, this general purpose or this general purpose, depending upon the chips that I'm using. So I have a lot of different places I can store different information. Once I've added those in my CPU, that just lets us, so when we're reading code, we know when there's huge breaks between stuff, we know where we were at the beginning and at the end. The next thing I need to add is where my org statement is. This is to tell the chip where to begin from. So org begin. I'll be looking in your guys' code for all this stuff. Some of it you have to put in to even get it to run. So I'm going to do 2 tabs over and do org 2 tabs 0x000. So this is the beginning of the program. This is where when the processor opens up, this is where it goes to. So I'm going to say go to setup, because later on I need to have a setup. And then I'm going to say org 0x004. What that does is anytime that there's an interrupt, it goes to this location. I'm going to say go to interrupt. This program is case sensitive, so whatever you give something a name, setup as a name, interrupt as a name, all these different things are names. and I'm going to type in go to begin, main begin. Okay, so that is to tell my processor what to do as soon as it turns on. Since I've used these names, I have to enter them in somewhere. So for my next one, just to save time, I'm just going to type in setup. There's nothing going to be in my setup at the moment, just to show you how to compile this program. Once I have setup, it's going to go in there, it'll do some things, and at the end, I'd say go to main begin. After my setup, I would put in my interrupt statement. Now we're not using interrupts at the first time, but in case somebody enabled it, I want the processor to know where it needs to go. So interrupt, and in here, I'm just going to say Rafi, and that's return from interrupt and enable flags. After I have that, program. I always put the main program at the end, that way if there's a problem and I go to where I'm not supposed to go, I end up back into main. So main begin. And I always have to have an end statement. If I don't have an end statement at the end of my program, this doesn't work. Okay. As you can see, I'm trying to keep things within columns. That way the program knows where it's trying to go and what it's trying to do. Now I should be able to come up here to this hammer and it says build main project. I click on it. Down here it's going to switch to my output. As it's thinking about it, I got an error in there and failed build. If I go up to my error, just scroll back up and I double click on it, it tells me where it was and what was wrong with it. It did not like 1, which it should have liked. So let's get rid of 1 and put it at the end. Count 1. And let's try it again. So I got a couple warnings, not really caring about warnings, but I built successfully and it took 4 seconds, which doesn't matter too much. So once I have a build successful, I can start adding in my program. The first thing that you'll want to do in your program is go back up to your setup and make sure that you can get an LED to turn on. So I'm going to say my LEDs are on port B. So I'm going to take my tris and I'm going to set it up as an output. So I'm going to say move the literal W 0x00. And I'm going to say move W to F to, oh, I skipped a step. Anyways, I'll type it in as tris B. Now before I should have done any of this, I should have said bank select, and I'm going to say tris B. And the reason I'm doing that is I have to select which bank I'm talking to. So if we're looking in here, when I started up, I was most likely in bank 0. I needed to change to bank 2, well, bank 0, go to bank 1, because tris B is in bank 1. By doing a bank select, that is changing which bank I'm actually talking to. So if I bank select tris B, move the literal 0, 0 in there, that sets everything as outputs, and then move W to F, tris B. Now in here I could also do a bank select port B, and then move the literal W of 0x00, and move WF of port B. So that'll make sure everything's turned off. In my begin main, with my oscilloscope hooked up, I can go in and do bank select port B, move the literal 0x00. This is kind of redundant, but, and then move WF, you'll see why here in a second, port B. Okay, now if I take this whole line of code, I do a copy, I do a paste, line it back up, and change this to FF, and then I need to come down here and say go to main begin. Okay. Now this has made a while loop. This will go forever and not come to end. If I don't put this in here, it'll do this once and then end. By putting this in, it makes it go here, complete this, goes to here, completes this, and it just goes on forever. Now if I build this, shouldn't get any errors, and it should go through, so build successful, so we're great there. I could press this button and make it go down to my chip, and what you should see is if you put your probe on the output of one of those port pins, you'll see it toggling back and forth between high and low. Now your high time should be shorter than your off time, because this takes 2 microseconds to do it with a 4 megahertz crystal, and then you have 1 microhertz. So 1, 2, 3, 4 microhertz. Sorry, not hertz. 4 microseconds to complete this, where this will take 2 microseconds. Except for go choose another 2. It might be close but the same, because this will take 2 to do as well. If you find out that they were off a little bit, you could put in a no op, which will add another microsecond in there of delay. And this is a basic program just to make sure that your chip is working and be able to get your program running. You always want to make sure that you're doing this. There is one stipulation with port B that you'll need to add in is there's analog pins on your port B on a few of the pins. You need to make sure that you turn those off so that it doesn't interfere with output. The book does say on port B that it shouldn't, but that's not always guaranteed. And so what you do is you do a bank select analog select high. Believe you put those to 0 and you're ready to go.